Okay, we got our SOHCAHTOA. I know that might look like an N, but it's not. That's SOHCAHTOA. We got SOHCAHTOA written out. And what we're going to do is we're going to get our trigonometric ratios. We're going to get them all written out. But first, we got to analyze this pen. Not pen, marker. I just bought it. I don't know if I like the thick markers like this. I'm not sure. Whatever. Okay, let's get into it. Let's say we have a right triangle. Mind you, what we've been learning with the trigonometric functions. Actually, you know what? I'll explain it in another video. Whatever. Okay, let's get a right triangle. Ah man. Whatever. Right triangle. There we go. So we got a right triangle. Let's say this is 4. This is 7. We're trying to find and we got to find the hypotenuse. Actually, no, I'll just tell you the hypotenuse. No, I can't. We got to find the hypotenuse for this. So when we find the hypotenuse is equal to, c squared is equal to a squared plus b squared. This is a and this is b. So a squared is 40. A squared is 49. 4 squared is 7 squared is 49. 4 squared is 16. Add those up. That is 65, I believe. So 65. And so if we square 65, then h will be equal to square root of 65. There we go. So we found the hypotenuse. Square root of 65. Now let us find a trigonometric functions for this. Ratios. Okay, so let's say this is angle theta right here. This angle right here is angle theta. Okay? And we're going to find sine first. Sine is opposite over hypotenuse. That's what the in sine, SOHCAHTOA is. SOHCAHTOA. Sine over hypotenuse. So sine of theta is equal to opposite over hypotenuse. Well, which is the opposite angle for this? This is the opposite angle. This is the opposite wall for this. And then hypotenuse is this. So this would be 7 over square root of 65. This trigonometric ratio, the sine for this is 7 over square root of 65. Because this is the opposite angle. This is the opposite wall, let's say, or side for this angle. But let's multiply this by square root of 65 so we can make it a proper expression. And this becomes 7 square root of 65 over 65 because the square root of two things is just that thing. Okay, now let's find cosine. Cosine of theta is equal to adjacent over hypotenuse. Well, the adjacent side is this side. This is the adjacent side because it's right next to it. And this is just hypotenuse. So we have adjacent over hypotenuse, which is 4 over square root of 65. Let's get the radical, which is the square root of 65, out of there again. Okay. We're multiplying both by square root of 65. Square root of 65 and 65. Okay, so the cosine for this angle theta is equal to 4 times the square root of 65 over 65. And let's do tangent of this. And tangent of theta is equal to the opposite over the hypotenuse. No, wait. No. Sorry, I wrote that down wrong. It's opposite over adjacent. What am I doing? That's what the TOA stands for. TOA. adjacent. What happened here? Somebody murdered my tangent. Tangent of theta. Okay, so opposite over adjacent. This is the adjacent side. This is the opposite side. So opposite 7 over 4. There we go. That's our theta for this one. That's great. That's great. That's fantastic, man. But what about another triangle? What if we were to do a triangle like this? What if we got another right triangle? Dang it, I'm so bad at writing straight lines. What if we got another triangle like that? Man, okay. And another right triangle. This side is like 6, and this side is like 3. So this would be, so c squared would be equal to 9 plus 36, which is 45. So the hypotenuse is equal to 40 square root of 45. Square root of 45. So yeah. And then I could simplify the square root of 45 down to, actually I'm not going to do that. We're just going to keep it the square root of 45. And let's say we have this angle, this is 90 degrees, and this angle, which is 30 degrees. And this angle, dang it. This angle, dang it. Oh, take it. This angle right here, which is 60 degrees. And this angle right here is 30, and this is 90, and this is 60. They all add to 180. So, and let's say we're trying to find all the trigonometric ratios for this angle at angle 30 degrees. So theta in this case would be this 30-degree angle right here. Okay? So sine is opposite over hypotenuse. So the opposite for this one is this wall right here, this side right here. And then the hypotenuse is just square root of 45. So this is opposite, which is 6 over square root of 45. Multiply both sides both by the square root of 45 so we can get the 45 on top. Because for some reason, math people don't like it on the bottom. It's crazy, man. We have to do all this extra work just to appease the math society people. It's insane. Okay, now let's find cosine of 30 degrees, which is equal to the adjacent over hypotenuse. The adjacent is one right next to it right here, right? This one right here. So 3 over hypotenuse, and I'm just going to write it already down as that we've already done the simplification of multiplying both by the square root of 45. So I'm just going to write 3 times the square root of 45 over 45, just to speed it up because it's taking a while. And now tangent, which is opposite over adjacent. And the opposite right here over the adjacent right there. So the tangent of 30 degrees, of this 30-degree angle, is equal to opposite over adjacent, 6 over 3, which is just 2 over 1, which is 2. There we go. And yeah, so that's how you find, the trigonometric functions. Yeah, good job, guys. Stay in school.